This is SpaceTime Series 26, Episode 9. Coming up on SpaceTime, astronomers find the most distant star in our galaxy, new evidence for the potential habitability of Enceladus's oceans. And Elon Musk says Starship could be flying in a matter of weeks. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study shows that the furthest reaches of our Milky Way galaxy, a region known as the galactic halo, is so far away it almost touches the halo of our nearest big galactic neighbour, the Andromeda galaxy M31. Astronomers reached their conclusions after discovering more than 200 distant variable stars known as RR Lyra stars in the Milky Way stellar halo. The most distant of these stars is more than 1 million light-years from Earth. That's almost half the distance to our neighbouring galaxy Andromeda, which is about 2.5 million light-years away. The characteristic pulsations and brightness of RR Lyra stars makes them ideal standard candles for measuring cosmic distances. Of course, the sky's full of stars, some brighter than others, but a star may look bright either because it's very luminous or because it's very close, and even for astronomers, it's hard to tell the difference. But astronomers can identify RR Lyra stars by their characteristic pulsations, and they can then use their observed brightness to calculate how far away they really are. These new findings are helping redefine what constitutes the outer limits of our galaxy. It turns out the Milky Way and Andromeda are so big there's hardly any space between them. The stellar halo component of our galaxy is much bigger than the galactic disk, which is about 100,000 light-years across. Our solar system resides in one of the spiral arms of the disk, about 27,000 light-years out from the galactic centre. The middle of the disk is a central bulge, and surrounding it is the halo, a sphere containing some of the oldest stars in the galaxy. And this extends for hundreds of thousands of light-years in every direction. The problem is the halo is the hardest part of the galaxy to study because its outer limits are so far away. And the stars there are very sparse compared to the high stellar densities seen in the galactic disk and bulge. But the galactic halo is important because astronomers believe it's dominated by dark matter, and so it actually contains most of the mass of the galaxy. The study's lead author Yuteng Feng from the University of California, Santa Cruz, says previous modelling had suggested that the stellar halo should extend out to around 300 kiloparsecs. That's roughly 1 million light-years from the galactic centre. Astronomers like to measure galactic distances in kiloparsecs, with 1 kiloparsec equivalent to 3,260 light-years. The 208 RR Lyra stars detected by Feng and colleagues ranged in distance from about 200 to 320 kiloparsecs, and they're able to use these variable stars as reliable tracers to pin down distances. The observations confirmed the theoretical estimates for the size of the halo. The findings were based on data from the Next Generation Virgo Cluster Survey, a program using the Canada-France-Hawaii telescope to study a cluster of galaxies well beyond the Milky Way, known as the Virgo Cluster. The Virgo Cluster is one of the great galactic nodes in the large-scale structure of the universe, and it includes the giant elliptical galaxy M87. Feng says to get a deep exposure of M87 and the galaxies around it, the telescope also captured the foreground stars in the same field, and that was the data which they were then able to use for their halo study. This is SpaceTime. Still to come, new evidence for the potential habitability of Enceladus's oceans. And Elon Musk says Starship could be flying in a matter of weeks. All that and more still to come on SpaceTime. The search for extraterrestrial life just got a whole lot more interesting following the discovery of new evidence for tiny building blocks of life in the subsurface oceans of Saturn's ice moon Enceladus. The new modelling, reported in the journal PNAS, the Proceedings of the National Academy of Sciences, indicates that the Enceladian ocean could be relatively rich in dissolved phosphorus, an essential ingredient for life. One of the study's authors, Christopher Glenn from the Southwest Research Institute in San Antonio, Texas, says Enceladus is one of the prime targets in humanity's search for life in our solar system. It was NASA's Cassini spacecraft which first discovered that Enceladus had a global subsurface liquid water ocean after detecting plumes of ice grains and water vapor erupting into space from geysers in the icy moon's south pole tiger stripes. And Glenn says that these plumes contain almost all the basic requirements for life as we know it. He says while the bioessential element phosphorus is yet to be identified directly, his team have detected evidence of its availability in the ocean beneath the moon's icy crust. One of the most profound discoveries in planetary science over the past 25 years is that worlds with oceans beneath a surface layer of ice are common in our solar system. These worlds include the tiny icy moons of the giant planets like Europa, Titan and Enceladus, as well as more distant bodies like Pluto. Worlds like the Earth with surface oceans need to reside within a narrow range of distances from their host stars, what we call the habitable zone, where it's not too hot and not too cold for water to remain in a liquid state, essential for life as we know it, on a planet's surface. But subsurface water worlds can occur over a much wider range of distances, thereby greatly expanding the number of habitable worlds likely to exist across a galaxy. Glenn says the quest for extraterrestrial habitability in the solar system has thus shifted focus. Scientists are now looking for the building blocks of life in different places. These building blocks include organic molecules, ammonias, sulfur-bearing compounds, as well as the chemical energy needed to support life. Glenn says phosphorus presents an interesting case because previous work suggested it might be scarce in the oceans of Enceladus, and that would have been dim for the prospects of life. Phosphorus, in the form of phosphates, are essential for all life on Earth as we know it. It's essential for the creation of DNA and RNA, energy-carrying molecules, cell membranes, bones and teeth in animals, and even in the sea's microbiome of plankton. Glenn says the underlying geochemistry has an elegant simplicity that makes the presence of dissolved phosphorus inevitable, reaching levels close to or even higher than those found in modern Earth seawater. According to Glenn, the next step's clear. We need to get back to Enceladus to see if a habitable ocean is actually inhabited. Now, this all comes about because 5 years ago, NASA's Cassini spacecraft discovered hydrogen in a plume of gas and icy particles spraying out from Enceladus's south pole tiger stripes. That discovery meant the icy moon had a source of chemical energy that could be useful for microbes, if any exist there. The finding also provides further evidence that warm mineral-laden water is pouring into the ocean from deep-sea vents. On Earth, these sort of hydrothermal vents support thriving communities of life in complete isolation from sunlight. The Ion and Neutral Mass Spectrometer Instrument Team lead, Hunter Waite from the Southwest Research Institute, says Enceladus now appears to have all three of the ingredients scientists think life needs: liquid water, source of energy, and the right chemical ingredients, like carbon, hydrogen, nitrogen, oxygen, and now phosphorus.
The instrument acts like a human nose, analyzing the smell, so to speak, or the composition of the gases in the environment. There was a significant amount of molecular hydrogen. The existence of molecular hydrogen, at least within the Earth's ocean system, is like a food source. It's candy for microbes. They eat the hydrogen, they turn it into methane. And with our findings, we were able to not only find out that there was H2 in the system, but to examine the chemistry that's associated with that process of taking hydrogen and turning it into methane. Here on Earth, the hydrothermal systems known as white smokers have water-rock interactions that lead to the release of molecular hydrogen in a similar fashion to apparently what's going on at Enceladus. This is just the final step that shows that there's molecular hydrogen being produced by these same hydrothermal processes, and that molecular hydrogen has the chemical energy to support microbial systems in the interior ocean. It's not demonstration of finding life, but it shows the potential for the existence of life in this interior ocean.
Of course, the wealth of discoveries now coming from Enceladus were only ever possible because of Cassini's detection of strange magnetic anomalies in the ice moon's vicinity. But it took a series of close flybys of Enceladus to detect the icy plumes and understand what they meant. This report from NASA TV.
In February 2005, we had our first close flyby of Enceladus, and the magnetometer signal saw something unusual.
What a magnetometer does is it measures the magnetic field in the vicinity of the instrument. We had a look at the wiggles, and they looked strange. The magnetic field of Saturn is moving towards it, and it couldn't penetrate down onto the surface, which was pointing to an atmospheric signature of some kind.
Here it looked like it had a tiny atmosphere. In March, we came even closer, looking for that same strange signal.
What it showed was that the signature, the atmospheric signature we were seeing, was focused at the South Pole. It was almost like there was a cometary plume of water vapor coming off from the South Pole.
People were saying, it's got to be jets, it's got to be jets. And the imaging team was saying, no, we don't want to say that, until we're sure. And so we went closer. We came within 175 kilometers of Enceladus.
Then we got the data back, and it was spectacular.
And then we found the evidence. Geysers coming out of the South Pole with water vapor and water ice particles. There were active geysers at the South Pole of Enceladus.
Because we were so close, all of the other instruments were able to take really good data. And we put together all of this data. We saw the cracks, the tiger stripes of the South Pole. We saw heat leaking out from these tiger stripes. On subsequent flybys, we found organic material, dust, water vapor coming out of the plume.
The Cassini discoveries in the first 3 flybys were so amazing, we changed our focus and added 20 more flybys of Enceladus, including 7 through the icy jets. The surprising magnetometer reading led us to the liquid water ocean underneath Enceladus's icy crust. After over a decade of research with Cassini, we now know there's a potential for the ocean on Enceladus to support life. And that has altered the way we think about where life might be found in our own solar system and in the worlds beyond.
And in that report from NASA TV, we heard from Cassini project scientist Linda Spilker and Cassini magnetometer principal investigator Michelle Doherty. This is SpaceTime. Still to come, SpaceX boss Elon Musk says the first flight of the world's largest rocket, Starship, could take place either late February or early March. And later in the science report, uncovering 29,000 years of Aboriginal history in the South Australian Riverlands. All that and more still to come on SpaceTime. SpaceX boss Elon Musk says the first orbital flight of Starship, the world's largest rocket, could take place either late in February or early March. The 120-metre tall Starship mega rocket towers over NASA's Artemis Orion SLS space launch system, as well as its predecessor, the mighty Apollo Saturn V moon rocket. When it launches, Starship will become the largest and most powerful man-made rocket ever flown into space. In fact, with over 17 million pounds of thrust, the Starship Super Heavy booster will produce nearly double the power of the SLS. It appears SpaceX have selected prototype Super Heavy Booster 7 and Starship Variant 24 for the historic test flight, with both stages subjected to a series of tests at SpaceX's Starbase facility in southern Texas. Both Super Heavy Booster 7 and Starship 24 have already performed static fire tests of their Raptor engines. While Starship 24 lit up all 6 of its Raptor engines simultaneously, Super Heavy Booster 7 only triggered 14 of its 33 engines in a single burn. That means additional ground testing will still be needed before any maiden flight can be considered. So when it does get off the ground, what will this monster rocket's mission look like? Well, the orbital test flight would see Super Heavy Booster 7 carry Starship 24 to an altitude of about 65 kilometers. Then, following main engine cutoff and stage separation, the booster will return to Earth, splashing down in the Gulf of Mexico off the coast of Texas. However, the ultimate plan will see the Super Heavy booster undertake an orientation flip, then a boost back burn, guided by nitrogen jets and aerodynamic fins, back towards the launch site. An entry burn will then slow Super Heavy down for a controlled descent, before a landing burn will see the booster touch down vertically back on the launch pad, caught by a pair of mechanical arms. Meanwhile, during this test flight, the Starship 24 upper stage will complete one full orbit around the planet before re-entry and splash down in the Pacific Ocean off the coast of Hawaii. Eventually, Starship will also land vertically back on the ground. The orbital trial will be the system's first test flight since May 5, 2021. That's when Starship prototype SN15 launched from Starbase, climbing to an altitude of 10 kilometers on 3 Raptor engines and undertaking a series of aerial maneuvers before landing back at Starbase. So far, all flight tests have only involved Starship prototypes. The Super Heavy boosters are yet to fly. So, what's SpaceX's Starship program all about? Well, there are 2 parts to it. There's the Starship itself and the Super Heavy booster. The 120-ton, 50-metre tall Starship is 9 metres in diameter and constructed out of stainless steel. It's powered by 6 liquid methane and oxygen-fueled Raptor rocket engines, 3 configured for atmospheric flight and 3 for the vacuum of space. Starship's 70-metre long, 9-metre diameter, 230-ton Super Heavy booster is also constructed out of stainless steel, and it's equipped with some 33 Raptor engines, all configured for atmospheric flight. Elon Musk sees Starship as an interplanetary colonial transport system designed to establish and then supply human settlements on the Moon, Mars and across the solar system. It'll be fully reusable, equipped with a belly heat shield and its own retractable vertical landing gear, and it can be refueled in space using unmanned versions of Starship. Another version will be equipped with a large payload bay for the deployment of satellites. Further in the future, Starship may even host point-to-point flights around the Earth for people, allowing you to pretty well reach any destination on the planet, or at least a nearby hub, in under 90 minutes. Starship's first mission is to provide the Starship Lunar Landing System, or HLS, a reusable shuttle for NASA to transport people and up to 100 tons of cargo between the lunar surface and orbiting spacecraft, such as Orion capsules and the Lunar Gateway space station. SpaceX plans to eventually use Starship to replace all the company's existing spacecraft, including Dragon capsules and both the Falcon 9 and Falcon Heavy launch systems. It's all an ambitious plan right now, but SpaceX does have a proven track record. Meanwhile, SpaceX has launched another 40 broadband internet satellites for rival company OneWeb aboard its Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida. With some 542 satellites now in orbit, OneWeb has over 80% of its first-generation constellation complete. These satellites were originally meant to fly aboard Russian Soyuz rockets. But the European Union's ban on using Russian rockets following Moscow's invasion of Ukraine means OneWeb's transferred its launch manifest to SpaceX and India. The OneWeb launch was followed just days later by the safe return to Earth of a SpaceX Dragon cargo ship loaded with 2 tons of completed scientific experiments and equipment from the International Space Station. The Dragon splashed down in the Gulf of Mexico off the coast of Tampa, Florida, completing the SpaceTime mission, which had launched from the Kennedy Space Center just 6 weeks earlier. The equipment brought back to Earth included hardware used to grow plants in microgravity, a bioprospecting experiment that ran aboard the space station, and the AstroRad vest, which was designed to help protect people from radiation exposure. Crew members on station took turns in wearing the vest during their day-to-day operations and then report on how comfortable it was or wasn't and how easy it was to carry out their day-to-day working duties while wearing it. The garment could eventually be used to help provide radiation protection for crew on Artemis missions to the moon. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.